This is project 12, our fourth technique project, and we're going to go back to project 10 and fix its glaring bugs. All the names and faces you add to the app don't get saved. This is an app designed to save names and faces, so which makes the whole thing completely pointless. For more information, go to the website at hackingwithswift.com, where you can buy this video and all the videos in the series in high definition, as well as ebooks of the same tutorials teaching you far more information starting at just $3. Buying the books and videos really helps support my work, so please at least buy something. Otherwise, grab me on Twitter. I am at 2straws. I'm happy to answer questions, take feedback, listen to your suggestions, and so on. No hate though, please. Hate can go to somebody else. So if you want to get in touch and I have the time, let me know. I am at 2straws. So we're modifying project 10, our names to faces application. And if you have not already taken a copy of it, do so now. I have copied mine and called it project 12. You'll see inside though is just project 10. To remind you of what it does, go ahead and press run straight away and you'll see the app running. And I actually choose iPad. I think iPad's a bit clearer to see what's going on. Hello, iPad. There we go. iPad 2, just like before. And there we go. I can press add. I can choose a picture. I'll add that leaf thing. Press use and name it my best pal Leafy. And then add some more. That waterfall and call him waterfall, whatever you like. There we go. So that's what the application does right now. Really cool. I can remember Leafy's name and waterfall's name. Amazing. But if I stop the app and rerun the app, you'll see a problem. It's all gone. That makes the app totally useless. So we're now going to try and read and write user data back to the disk as needed. And an easy way to do this is called NSUserDefaults. And it lets you store any basic data type for as long as the app remains installed. And you can write basic types such as booleans, floats, doubles, ints, strings, or even NSURLs. But you can also write more complex types, including arrays, dictionaries, NSDates, and even NSData values. If you remember, NSData holds basically any kind of data. When you write your data to NSUserDefaults, it automatically gets loaded back in when your app runs. So you can read it back again and start using it. This makes it using it really easy, but it does mean it's a bad idea to store lots of data in there, because it means a very long loading time when your application starts up. So if you're thinking, well, I want to store at least, say, 100K of data in here, don't use NSUserDefaults. It's the wrong choice. Do something else instead. So what we're going to do is temporarily leave this project behind. Okay, we're going to create a new single view application. So go to File, New Project, choose iOS Application Single View, and I'm going to call mine Testy. Really doesn't matter what platform it's for. I'll choose iPhone and press Next. Save to desktop. And all we're going to do now is just fiddle around a little bit with NSUserDefaults so you can get a feel for it before we actually modify the code for our project. So open viewcontrol.swift and in view.load, write this. Let defaults, a new variable called defaults, equals NSUserDefaults.standardUserDefaults, the system's built-in way of letting you read and write data. Once that's done, it acts like a dictionary. You can read and write things based on a key name so you can reference it later. Now these values nearly always, there are some exceptions, but nearly always have no meaning outside of what you use them for. So just make sure the key names are memorable to you and you're okay. So with that constant defined, we're going to try and write an integer. So you'd say defaults.setInteger, a value, I'll say 25, for key age, like that. Or we can have defaults.setBool, value true, for key use touch ID, like that. We can say, save a double, defaults.setDouble, mpi, the value of pi, for the key pi, like that. Now, in older versions of iOS, you were required to call defaults dot synchronize, which meant write this thing to disk now. As of iOS 8, that's no longer a problem. Don't use it. Apple recommend against using it now. So with set integer, set bool, set double, we're obviously setting exact data types. There's also set object, which lets you write any object type that supports NSUserDefaults. For example, we can say defaults.setObject, Paul Hudson, 4-key, most awesome person ever. Whatever you want to write in there. And that will write that object, Paul Hudson, for that key. Or you could say defaults.setObject, a new NS date, a date value for the key last run. So the app was last run on that date. Boom, done. And even if you're trying to save complex data types, this thing just laps it up, really. So we can say let array equals hello, then world, and say defaults.setObject, array, 4-key, and we'll call the array a key saved array, like that. That'll write out the array of strings to disk under saved array. Same for dictionaries. We can say let dict equals name is Paul, and country, as you may have gathered after all these videos, is UK. And then defaults.setObject dict, 4-key, saved dict. These key names are totally down to you. You can call them whatever's useful to you. So that's how you write stuff to NSUserDefaults. Reading is just as easy. So, but there is one proviso, which is about return values. So you have to know exactly what you're looking for. You can say integer for key. It returns the integer of the key if it exists, otherwise 0 if it did not exist. Bool for key returns a boolean if the key existed, or false if not. Float for key, float or 0.0 if not. Double for key, double if it exists, or 0.0 if not. Object for key returns any object optional. Optional any object. So you need to conditionally typecast it to your data type. Now, knowing these return values is actually quite important, because if you were to do something like this, defaults.bool for key, use touch ID like that, right? That will remember if the user wants to use touch ID or not. But if they chose no, we can't tell the difference between that and not even existing. Because if this key does not exist, it will return false. If it does exist and is false, it will return false. So bool for key should be used very carefully. You generally want to check for things that are true, so you can clearly see a true return value. Otherwise, just ignore it, pretend it was not set at all. Same for integer. Don't try and look for integer 0. Don't try and save a value 0 for integer, because you simply can't tell whether it's 0 or just not set, just by using the integer for key, which looks like this, defaults.integer for key. So by using these methods, just check the return value very, very carefully so you know exactly what you're getting. So with object for key, it will actually cause you a bit of bother, because you get an optional back. So you're faced with two options here, one of which really, quite frankly, is not smart. So you realistically have only one option. So your options are use as to typecast your object to what it should be, or use as question mark to optionally typecast your object to the type it should be. Now, if you use as and object for key returns nil, you will get a crash. So I want to read out array here. I'm going to say let loaded array equals defaults.object for key saved array. If this returns nil, and I say as an array of string, that will crash, because nothing will come back from this. It tries to force it into a string and it will fail. So please don't do that. You want to typecast these things very carefully. Equally, using as string is quite annoying, because now loaded array is an optional array of strings as opposed to an empty array of strings, which is what you really want. You want to say, listen, either load the array of strings or give me an empty array. Fortunately, Swift has a solution for you. It's called the nil coalescing operator. It looks like question mark, question mark. And what it means is, look at the left-hand side of the equation. In this case, it'll be this array that comes back. And if it is nil, use something on the right. Otherwise, unwrap it. I'll write the code and show you what it does so you can see what it really means. Once you want to see it, it's quite clear. So we have here default object for key saved array as string, then string array, parentheses, like that. And what will happen is it will look at this thing here and say, does it exist? Yes. Can I convert it to an array of strings? Yes. Do so. So it becomes an array of strings, unwrapped already, ready to use. If it does not exist, or it cannot be converted to an array of strings, this will fail, and instead we'll get back an empty array of strings. So now if you look at loaded array, you will see it is an array of strings rather than an optional array of strings. Much nicer. So if I take that out again, you'll see loaded array is an optional array of strings, much more annoying to use. And this also works for dictionaries. Now we could have written here let loaded dict equals defaults.object for key saved dict as so conditional typecast string : string, so a dictionary with a string for key, a string for value. If that fails, then nil coalescing operator creates a new string, a new dictionary, empty, so we can do things with it. So that's the basics of working with NSUserDefaults, but we're just getting started. You see, above and beyond integers and dates and strings and arrays, you can also save any kind of data inside of NSUserDefaults as long as you follow some rules. So what happens is simple. We're going to use a method called archived data with root object of a class called NSKeyedUnarchiver. We just met NSKeyedUnarchiver, and this is its brother. And it turns an object graph into an NSData object. And by object graph, I mean your object plus any objects it refers to, plus any objects they refer to, and so on and so on and so on, like a little tree of objects. As long as all the things in the graph match 3 rules. So the first rule, all your data types must be one of the following: Boolean, integer, float, double, string, array, dictionary, or NSDate. If your data type is a class, i.e. not one of those, but a new class you have made, then it must conform to a protocol called NSCoding, which is used for archiving object graphs. And finally, third rule, if your type is an array of dictionary, all the keys and values must match rule 1 or rule 2. So it must be one of those basic data types or a class that supports NSCoding. Now, many of Apple's own classes support NSCoding already, not limited to UI color, UI image, UI view, UI label, UI image view, UI table view, SK sprite node, and more. And that means you can literally configure an SK sprite node exactly as you want, a whole SK scene, in fact, of stuff, and write it out to a file and load it back out again using this technology. For free, it's all done for you because those things support NSCoding already. So if we want to save our array in our program, I'll go back to it now, get rid of that thing, go back to our view controller here and see we've got this person array of person objects. If we want that to write to NSUserDefaults, we have to make it conform to the NSCoding protocol. So the first step is to modify the person class here. So it says class person NS object, comma, NSCoding. Now this is where things get a little bit interesting because in Swift you can have classes like this person, or you can have structs. And structs and classes are very, very similar with a few minor differences. One of them being that NSCoding requires you to use classes. Another one being that classes can inherit from each other. So, UI table view controller inherits from UI view controller. And also structs have a really brilliant thing, which is sadly not in classes, called member-wise initializers, which are really cool, but for another day. We have to, if you want NSCoding support, we have to use class person with NS object like that, exactly like this. Which means if you were back in Project 10 screaming at me, don't use a class or person because you're a super cool coder and you know more than I do, you are wrong. You have to use a class or person. If you try and use a struct, it will not work. You have to inherit from NS object, otherwise it will not work. NSCoding requires these things. But as soon as we say we're supporting the NSCoding protocol, errors come along, which is bad. But the errors come because NSCoding requires two methods, a new initializer and a new method called NCodeWithCoder. So we're going to write some more code to fix the problems. And although the code's kind of similar to what you've seen already in NSUserDefaults, it has two things you need to be aware of. First, we're using a new class called NSCoder. This is responsible for encoding, i.e. writing, and decoding, i.e. reading your data. So it can be used with NSUserDefaults and elsewhere. Second, the new initializer must be declared with a keyword called required. This is something Swift's very picky about. And it means if anyone tries to subclass the person class, they are also required to implement this method. And it's important because it means that as a person class, we are implementing the NSCoding protocol. If someone implements a subclass of person, say office person or sports person, they must also support NSCoding like we do, so it works correctly all the way up the stack. So we're going to add these two methods now, and they're not difficult. The first one looks like this: required init coder ADcoder, like that. And you, again, use code completion, and that means init with this NSCoder, init with this available for reading your data from. So we can say in here name equals ADcoder.decode object for key. Oops, that's a mistake there. Object for key, and we'll use the name. And then image equals ADcoder.decode object for key image. Now you can give these things again any names you like. It's down to you. I tend to give them the same names as my properties just for easy referencing, but it's down to you. You do need to typecast this because decode object returns any object. We've got no idea what it returns. So you want to say at the end of it as string to say this is definitely a string, like that. There we go. And that's that method done. That's loading off disk. To write to disk, you want to implement NCodeWithCoder, like that. And then you get a coder coming in as a parameter here. So we'll say a coder.encode object, and we'll give it a key. So the object is our name, so we'll just type in name. Key is name, lowercase n. So it matches whatever you put in here. That's the only thing that matters. Make sure it matches decoding and encoding. Then a coder.encode object, image for key image. And that's all it takes to make our person class successfully load and save from NSUserDefaults. We haven't actually called the saving code yet. This is just if we ever do decide to load and save it, then do so. The next step is really to add the functionality to load and save stuff. So go back to viewcontroller.swift, and we're going to add the code to load and save. Firstly, we'll make a save method. This is important because anywhere that we save, we want to write it out to disk, right? So for example, when you add a person, you want to save. When you change their name, you want to save. If you extend it in the future, when you delete someone, you want to save, right? So rather than writing the same code again and again and again, we'll make a save method at the bottom here. Func save, open brace. So here is where NSKeyedArchiver comes in. Now in the last game, the pachinko game, you saw NSKeyedUnarchiver being used to load a particle emitter from disk. So NSKeyedUnarchiver does the unarchiving. We'll use NSKeyedArchiver to make an archive of our stuff. So we'll say let saved data equals NSKeyedArchiver archive data with root object. And we'll specify our people array like that. And we'll get an NS data back ready to use. We now get an access to a variable for our NSUserDefaults. So let defaults equals NSUserDefaults dot standard user defaults. Then we just say defaults dot set object saved data for key people like that. So create an NS data from our stuff, which will in turn call encode with coda for every one of our objects in the array. Put it in here, get access to defaults, and write it in. That's it. That's all it takes to save stuff. Very, very simple. Now we do need to modify our code so that we it's call save. So here you can see we have did finish picking media with info. So we're adding a picture to our collection view. We reload it here. We also want to save. So we'll just write in save. So it saves people at that point. And similarly, we want to save where we also have the renaming, which was up here, reload data. So we want to say, we're inside a closure by the way, so it must be self.save, like that. So it writes it out in both places. To do the reading is hardly much more difficult, to be honest with you. Up here in the viewDidLoad method, we want to say, do we have a saved people array? If so, let's use it. So we can do that by saying, let defaults equals NSUserDefaults dot standard userDefaults. Then an if let to conditionally unwrap if it exists. If let saved people equals defaults dot object for key people. Then conditionally typecast as NS data. That's what we wrote out. That's what we should read in again. So if saved people becomes set, i.e. if this people thing exists as an NS data, then we'll use NSKeyedUnarchiver just like we used to create the particle emitter. So we can say people, i.e. our people array, equals NSKeyedUnarchiver dot unarchive object with data, and we'll choose saved people. That is it. So this thing here loads it from disk. This thing down here writes it back out again. You should be able to run that now, hopefully, and see it work. So we'll run it back. Oh, we've got an error. What's my error? What did I do? Oh, because, I see why, sorry. Again, we are unarchiving an object with an unknown type. It's just an object. We need to tell it is an array of person. Sorry, I'm being slow. There we go. Go ahead and press play. And there's our thing. So we can go ahead and add to that. Let's add one here, use, add another one from there, use, add another one, that one, use, and we'll give him a name. He is, of course, Leafy. Then we'll quit the app and relaunch the app. Boom. Exactly as we left off. So we're now successfully saving and reading data from disk. It's much, much nicer application now. It's much more useful application because it actually is doing what it's supposed to do, which is a good thing, obviously. Now, I can promise you, you will use NSUserDefaults in your projects. You just will. That isn't some sort of command, just a statement of how inevitable it is. It really is that common. If you want to save any user settings, you want to use program settings, it's just the best place for it. And I hope you'll agree, it is remarkably easy to do. As long as you support NSCoding, you can save your own custom classes in there. There is one proviso that you need to be aware of, and we'll come back to this much later in Project 28. NSUserDefaults, you should not consider it to be secure. So if you have confidential user information or anything private, do not write it to NSUserDefaults, write it to what's called the keychain. And that comes in Project 28. Do not jump there now. Work your way through because there's still a lot more to learn. As a reminder, go to our website, hackingwithswift.com, where you can find this tutorial as a book with lots of information in there. It just costs you $3. Or you can buy it as a video in beautiful high-resolution graphics to admire Leafy in his glorious colors. And doing so really does help me support myself to make more videos like this one for everyone to enjoy. Alternatively, find me on Twitter. I am at 2straws. If you have problems, questions, feedback, love, you want hugs, you want friendship, you want to chat about books, bring it on. Come and chat to me. If I have time, I'll help you out. Have fun, and by all means, go and extend this project to do many, many more great things. I look forward to buying it on the App Store soon.